All right, math, this is the day 54 lesson. It's on functions, and we're going to deal with something called piecewise functions. All right, so again, this is an A-B problem set, and so I'm going to walk you through the A problems. The B problems are not identical, but they're pretty close, and they'll teach you the concept. You'll learn the concepts to do them. All right, so what is a piecewise function? Very simply, if a function just continuously goes from side to side, there's no breaks in it, that's called a continuous function. If a function has breaks in it like this, that's a discontinuous function, but they give it the name piecewise because it's broken into pieces. So that's an example of a piecewise function, and you'll notice these functions you see down here are piecewise functions. So what we're going to just learn is the notation and how to answer these questions, okay? So this first function comes down to here. It comes up to, it looks like about x equals 2, but doesn't touch x equals 2. Remember that an open circle means that it's not actually touching 2. It's going all the way up to 2, 1.99999, but it doesn't actually reach 2. So where is 2 in this case? Well, there you see a dot all by itself. So at 2, this is 6 on the y-axis, 1, 2, 3, 4, 5, 6. So 2, 6. Then there's another discontinuity in it up to here. So there's the 2 also, that is on the x-axis 2, but it doesn't include the 2. And so now it starts there, and from then on it comes on down here. All right, so that's how you kind of look at those functions. Okay, so what we're going to do is, what it's saying is it wants to find the value of y where x equals -2. So we come back here 1, 2 places, and the value of y is 1, 2, 3, 4. The lines are a little hard to see, but they're good enough. So there it would be +4 on the y-axis. So that would simply be a 4. And what about at f equals 2? Again, it means x is going to equal 2, so you come right there. And where x equals 2, where do you come up to? Well, this line, this particular function does not include 2. That's the round circle. But so the point of x equals 2 corresponds with y equals 6. 5, 6, it's right there. So it's 2, 6 right there. So that's going to be 6. Now what about 5? You come over to 5 and it's up 1, 2, 3, 4, 5. So that's going to equal 5. All right, so again, the circles, open circles mean that it does not include that point. A closed circle or a closed dot, solid dot, means it does include that point. All right, so you do the B problem, and we'll move on down here. And now here we have a function that comes down to here and includes the point x equals -2 right there. It would be -2, 1. So it includes that point. Then you have a new function, a different function rather, up here, and it starts at 2, but it does not include 2. They can't both include 2. That's illegal. A function, a particular value of x, cannot have more than one y value. So the y value here is 1, and this up here, which is 6, is not included. So it's really starting at 5.99999, and it's moving on down. All right. So here, -4, so you come back on the x-axis 1, 2, 3, 4 and go up 1, 2, 3, 4, 5. So that would be 5. Okay, f equals 0 is right here. X equals 0 is up 1, 2, 3, 4. And finally x equals 1, 2, 3, and that's up 1. And that's all you do for these. Okay, now we're going to do some where they're giving you numeric functions but not showing you the graph. And they want you to be able to determine what the y value, the output value, would be. Now, this got a little misaligned, so these two should be aligned to each other, just as these are aligned to each other here. So what is this saying? It's saying that if your value of x, and they're calling it t this time, it doesn't matter, it's your input value, is between 0 and 60, then your y value is going to be 20. If your value of t, again, that's your independent variable that you're plugging in, is greater than 60, then you've got to plug that number into this equation to get what your output value is. All right? So let's take a look at this. So when t is 30, well, 30 is between 0 and 60. that means your output value is going to be 20. It'll be 20 for anything between 0 and 60. That's what it's saying. It will always be 20. So what that means is if you drew a graph of this, I'll just draw a small graph here, and this is 20. From 0 to 60, I'll put 60 right here, it would be a flat line. Everything from 0 to 60 would be 20. Then once you get past 60, you're going to have to put t into this, and that's going to make it an upward sloping line somehow, okay? You don't have to draw the graph. So let's look at this. So if t is greater than 60, then you have to plug t into this equation. So there you go. C function of c, 100, is greater than 60, so you plug 100 in here. So it's going to be 20 plus 0.4 times, t is 100 in this case, minus 60. Okay, so it's just a math problem, and that should be a 60. Change that. Okay, so 100 minus 60 is 40. You multiply that by 0.4, and then you have 20 plus that right here. 0.4 times 40 is 16. 20 plus 16 equals 36. Okay, so that would be 36. And whatever the value is, it's greater than 60, so you'll find that would be some sort of upward sloping line right there. Until it gets to 60, it's exactly 20. That's what this says. And then once it gets past 60, t greater than 60, you have to plug the number into this equation. All right? You do this one over here. You have 3 different values. So if x is less than 0, meaning a negative number, you plug it into this equation. And if x is greater, 0 or greater, you plug it into this equation to get your answer. That's all there is to this. Okay? Let's keep going. So this one is very similar to 3b. So again, this got slightly misaligned, so it should look like that. Those two should line up, and these two line up with each other. So if x is less than 0, we plug the number into this equation. If x is greater or equal to 0, we plug it into this equation. So here x is minus 3, so we're going to use the first equation. 6 times minus 3 minus 1. That's going to give us minus 18. Whoops. That's going to give us minus 18 minus 1. Negative 18 minus 1 equals negative 19. So that would be this answer right here. How about if it's 0? Now be careful. If it's 0, it's got to go into the second equation because this means x is equal to 0 or greater than 0. So 0 is equal to 0. So it's going to go into the second equation. So 7 times 0 plus 3. That's 0 plus 3 is going to give you 3. This one is 4, so it's also going to go in the second equation because it's greater than 0. 7 times 4 plus 3. So that's 28 plus 3 is 31. And that's how you do these. They're not really that hard. Okay? So you just have 2 of those to do. Now let's go on and do some more of the graph, those on the graphing. Now this is different. It's asking you to find, this is kind of a combination of these up above, to find the domain and range of the following piecewise functions. Okay? So let's see how that's done. Okay, so domain, remember the domain is the values along the x-axis that are covered, and range is the y-axis. That's the output. So input is domain, output is range. Just remember that in alphabetical order, D comes before R, so the X comes before the Y, and so that's how you can help you to remember this. All right, so let's see what this would be. So it's a little hard to make out these lines, but I think they're good enough. You can see this is 5, this is 0, so this is going to be on the x-axis 1. So what is the domain? It goes from 1 to 5, and notice that those are solid dots, so it includes both 1 and 5. Then it skips over to about 7. This is 7, and notice it does not include 7. And then it goes all the way to forever, to infinity. Now the fact that it bends here doesn't matter. It's continuous along here, just because it doesn't look like a smooth curve, it's still continuous. So it's going to go from 7, but not including 7, up to infinity. If it goes off the graph like that, it means that it goes to infinity. So how do we write that? So you got to remember your notation for writing points. If it's a solid point, it's a square bracket. If it's an open point or infinity, in other words, a number that can't be reached, then it's a rounded bracket, a parenthesis in other words, okay? So the domain is on the left 1, and on the right it's 5. So you write it like that, 1, 5. Okay. Okay, and then the range is the y values for this particular function. And it goes, it's also two inclusive points. It goes from 1 right here up to 5. Now these look like negative signs, they're not. That's actually positive 5. So it goes from 1 to 5. So 1 and 5. So it's 1 on both domain and range and 5 on both domain and range. All right, now what about this? Okay, now in the x direction we go to this function. It starts at 7 on the x-axis, but it does not include 7. Okay, so this is this function. I'll draw an arrow down here. So the domain is 7, but not including 7. So you have to use a rounded bracket, a parenthesis. Okay. And on the right side, how far to the right does it go? It goes forever, since it goes off the graph. And you never reach infinity. So you write the lazy 8, and you write also a rounded bracket, okay, because it's never going to reach infinity. The range is going to start here on the y-axis, and if you look at that, that's 6. But it does not include 6. So it's a rounded, it's a 6, and then up. How far up is it going to go? Well, this line goes forever to the right and forever upward. This way and this way, so that means it's going to go to infinity also, positive infinity, and that is never reached, so that's a rounded bracket. Okay, so that's how you do it. Now you go ahead and do the B problem. Okay, so here we are, we're at 6a. So right here it starts on the left at x equals 1. We're starting with domain, that's the x values. And it starts at 1 but not including 1. And again, even though there's a kink in the line, you go all the way, it is continuous, so you go all the way to there. That's to x equals 7. So the domain of this line right here, I'm actually going to write it down here, is curved bracket because it doesn't include 1, and square bracket because it does include 7. So that's the domain of this line. The range, it starts at 1 and goes up to right here to 3. So you're interested in the up and down 1 to 3. So again, it doesn't touch the 1, but it does touch the 3 on the y-axis. So it's 3 with the square bracket. Square bracket means it's a closed dot. Rounded bracket means it's an open circle. Okay, now we use this domain to do this one up here. So this is going to start at 7, but not including 7. So it's going to start at 7, and it's going to go to the right forever because this goes upward and to the right forever. It goes to infinity. So again, you never reach infinity, so that's always a rounded a parenthesis like that. So that's the domain. The range is the up and down. So it starts here, but it doesn't touch that, and that's 5 on the y-axis right there, 5. And again, it goes up forever. So it goes up to infinity, and that's a rounded bracket. Okay, that's how you do it. So this is domain and range for this line. This is domain and range for this line. All right, you do 6b down at the bottom. It's got a few different lines, but it's no more complicated. Section 1, you can call this one. Section 2 is this one. Section 3 would be this one. All right. Okay, this one, domain and range, same thing. Now, there's actually 3. I only have the words domain and range once. So we'll write all the domains here and all the ranges here. So for this one, it starts at 0 and it comes over, that's a 5, so I'm going to say that's 4 right there, okay? So from here to here is 0 to 4, so the domain of this first line is 0, and it actually touches 0 because it's a closed dot. It doesn't touch 4 because that's an open dot like that. Okay? Now, the second domain is this right here. All right? And it goes from 4 to 6 because this line in the middle is 5. And it touches both of those. So what we're going to do is use something that's used in logic called a union sign. It means you put it together, and it just looks like a U. All right, so we're going to union this. So it's going to be 4, that point right there, over to 6, that point right there, and it touches both, so it's square brackets. And then we're going to union that with this. So if this is 6, then this right here is 7. Again, it's hard to tell. You can just make an estimate. That's 7. So it starts at 7, but it doesn't touch it, so it's a round bracket. And it goes up to here, and I'm going to say it looks like that's 10. If you look down there at the bottom, there's a 10. That's going to go to 10, and it does touch the 10. So that is a square bracket. Again, we're only looking at the numbers on the x-axis for the domain. Now we go to the range. It starts at 4 and it ends up at 6. You can tell because that's a 5. Again, it's not a -5, it's a 5. I'm not sure how that line got put there. So it goes from 4 to 6, but it doesn't touch 6. So how would you draw that? Square bracket for 4, rounded bracket for 6, like that. Now you're going to union that with this one. And on the y-axis, this is simply 5. See, it lines up with the 5 right there. So it's simply going to be square bracket 5. It just goes from 5 to 5, so you just have a single number there. This right here is 5 because of that. Okay, then you union that with this line. This line starts at, it looks like 6 right here, and it goes up to, it looks like about 9 right there. It doesn't touch the 6, so it's a rounded parenthesis, comma, and goes up to 9. It does touch the 9, so that's a square bracket. Okay, so just pause and study that, okay? And be sure you understand how all those were drawn into grammar. The union sign just means you're putting these together, even though they're separate piecewise functions. Okay, you do the same for this one down here. That's 7b. And now I'll go on to 8a. All right, so again, you got to kind of, if you just have to guess at what these numbers are, that's okay. So I'm going to guess this is about -2 right here. So this domain goes from -2 to 0, and it touches both of those points. So it's square bracket, -2, 0, square bracket. Now from here to here, we union that with a rounded bracket because it doesn't touch the 0. So but it is 0, it just doesn't touch it, to 2. And it does touch the 2, so it's a square bracket. Now we go up here to 2, but this one doesn't touch the 2. I'm going to run a little off my paper here, so I'll just put it down here. It's 2, and then it goes to 4, and it does touch the 4, so that's a square bracket. Okay, so these are the domain right here. All right, the range down here. This one is -1. It's -1 right there. It doesn't go up or down at all. It just stays at -1. So, and it touches both. So we're going to just put -1. We union that with this one. Okay, now we jump up to this one, and this one is at 0. Now, this one you might be a little confusing because this one, it doesn't touch the 0 there. It does touch the line there. The point is the line is on 0. So that is going to be a square bracket 0. So don't be fooled by one of them being rounded and one of them being squared. It's not. On the y-axis, this is entirely at 0. And then you're going to union that with this one. And again, don't be fooled by an open circle there. It's entirely at, what is that, 1, 2, 3. It's entirely at 3, so it's square bracket 3. Okay, and that's how you do these. Now you go do the B problems, and we'll give you help in class if you need it.